of the system is to analyze the system. And finally, or eventually, we should design the system. Yes, we should design the system. Now, here is this standard differential equation. Now, this is A-order differential equation. Where CT is the output and this RT is the input. RT is input. Now, here we should ask ourselves how to solve this equation. This, yes. Germany. But what method can help us to solve this differential equation? N order. Yes, differential equation. How to solve it? Have you studied
calculus?
The mathematical teacher have tell you how to solve this equation. Tell me. In general, the general method for solve the differential equation is for millimeter equations. So for the high order equation, differential equation, it is not useful. The general method is not useful. So we should use Laplace transform. Yes, Laplace transform. Now, for example, we can see the example the displacement system of spring mesh damper. Now, we should make this mathematical model for this system. Would you like to make a model for this system? Now, this
resistance spring?
Yes.
The spring has some K.
The spring coefficient is K.
The gravitational force is the pressure.
This is the input Ft. And this is the output. This
Xt.
Is the Ft is the output. The output is this display of this star. Now we can see what this how to give this equation of this system. For this system, we should analyze this force of this system, the mass. For the mass. Now, the force, P is take. Now, P is this gravity, mg. Now, this foreign force, now, Ft. And this branch give me a force. P is R. The R is R. Now, this we can see we have 1. And another, what's this? There is a force F. There is a force F. We show that when it is down along this way, and this force, the duration of this force is R. So for this mesh, there are 4 forces is on this place, and 2 is up, and the other 2 is down. And when and they use the distance between this and depart the order point xt. Now we should make much model of this system. Make model of this distance is ft down ft. Next, we show the length and inductor systems. Now, this component include the resistor. Resistor is used like this figure. Figure 2060. Now we can see. Now it is satisfy this equation that U equal to IR. And the second component is capacitance. Now I equal to C and duration U to T dt. Now the third is an inductor. The inductor. Now U is L is of this duration I to T.
Minus I is let's see.
Let's see. This is a very general example for inductor capacitance. The differential of RLC network. UC, we can see UC is the output voltage and UT is the voltage source. It's the voltage source. Now we show the build this mathematical of these systems. How to build it? Do you remember it?
Which one?
Which one? This one?
Yes.
RLC.
RCLC circuit. Resistor, inductor, resistor, capacitor circuit.
Where is it?
One nani hour.
এগুলো এখানে দিছে বাবা মাথা নষ্ট হয়ে যাচ্ছে
One nani hour nani খেলাধুলা করবো. Basically call that.
Now we show that give this differential equation.
কন্ট্রোলে এখানে দিয়ে রাখছে মা একটা
मैं हल्का सा कुछ चिकन ले लो अगर लोग की में बात काफी मीटिंग है ना सबसे टाइटल मीटिंग में रखता हूँ मैं
কিসের মিটিং
सिस्टम
ও না আমার একটা মিটিং ছিল তো এজন্য আসলাম
बराबर 3 मिनट
একটা মিটিং ছিল আমার কালকে সব প্রজেক্ট থেকে
This is the two differential equation is for these two examples. The first is for this mass, and the second is RLC electric system. These two differential equations.
Yes,
we can see this is two-order differential equation. Now, how to solve it?
solve
How to solve this equation?
how to solve
this one
Yes, the two. How to do this two? This one is for the best spring mesh diameter system. And the second equation is for the RLC network. Network. Now, the key important is how to know this equation. Now, these two words for mathematical methods tell us we only maybe slow one word or differential equation. Now, this is the two word.
For this M, this is the mass, And d square xt by dt square, we do a 2-time differentiation, and f dxt by dt we 1 time, and kx we just put the value and find the surface. This is second order differentiation.
Yes, the second order. Now, conclude. We can say differential physical properties can gain similar differential equations. Since the two systems is not different each other, but this differential equation may be similar to each other. Now, the differential equations reflect the essence characteristic of systems. These are R2, second order. Now, for the fact, the coefficient m, this coefficient is T1, T2. Now, also plus this first order equation. Now, here is this ft, this is you see. And ft and u can see is a consistent number. Now, this is another terminology of condensation is linear approximation of nonlinear equation. Now, a great majority of physical systems are linear within some range of these variables. However, all systems ultimately become non-linear. Maybe linear is a very short time or very short distance, but all the systems may be non-linear, as these variables are increased without limit. Now, second, a system is defined as linear in terms of the system's excitation and response. So, we should use the linear equation to approximate these nonlinear equations. Now, the relationship of two variables written as y equal to fx, where the fx indicates y is a function of x. Now, it is very easy. Now, the normal operating point is designed by x. The normal operating point is designed by x0. Because this curve or this function is continuous over the range of interest, and Kane series expression about this operating point may be RT9. Then we have this. We can see here this nonlinear equation can be approximated by a linear systems. We can say y equal to y0 plus delta y, f equal to fx0, and plus this deriving fx to dx at this 0 x0, and times dx and then plus etc. Now we can see here this nonlinear the equation can approximate by linear system. This is Taylor series. Taylor series. Now we stop at this point. Now x is to x0. Now y can approximate by y0. Y0 is also fx. 0. Delta y also is the derivation of df to dx at this place of 0. And then show the times delta x. So this delta y, we can see here, this is the delta y. Delta y also is this part. this part.
I see.
This m is the slope at the operating
Point.
point. This slope is very easy to understand. We have studied in mathematical. Now, this is
মাথার উপর
এটা খেলে দিবি
a cap in this plane, and it is not linear, non-linear. Now, the differential of this place we can say here. Now, this slope we can say also we can say the differential of this function at this point.
y equal mx,
The slope yes,
otherwise delta y equal m del x.
yes. Now we can see here like this.
So now
Del x del y.
what?
You want to?
I want to.
Now this is the initial point x0. Now this is the function value y. Function value y0. Y0 is correspond to x0. It is also this function value of x0. Now, this blue line curve is this function, is the figure of the function.
Function.
Yes, this line.
Put malani.
Okay.
Tan theta equal m del y by del x. Y, this is y point, y minus 0.
Yes,
X
theta
minus 0.
y.
So this is delta y by del time. So delta y equal m del x. Huh?
Yes.
This one. Delta y equal m del x.
Theta y.
Equal m del x.
Theta y equal to m.
Del
Theta x. This m
This
is also this
slope.
slope of the line.
So this is
Yes.
how delta y equal m del x.
yes.
And this is equal.
Yes. Now, here example. This is a nonlinear differential equation. We can see here it is first order conversation. Now, dt to dt, ddt to dt. Now, plus t ratio to r. Now, here is this equation. The opening point is t0,
Here,
u0. Now, t is equal to t0 plus
Delta
t. U is equal to u0 plus
Delta
delta
u.
u. This is a small change. Like this.
Small
And
change.
then we have this Taylor series. Have this Taylor series.
Taylor.
Yes,
Taylor.
Taylor series. Now, linear approximation of differential equation we can see here. Now, here is C. This is the differential of t0 plus delta t to dt, and plus this t0 plus delta t to r equal to 0.24 to
Wow.
r, and this plus. We can see how to make this equation simplify. Now, make this simplify like this. This dt0. Now, it is a constant number.
Yes, okay.
So, it is dt to dt0 to dt is 0.
Zero.
Yes, it is 0. Now, so this part is equal to this part. And we can also say t0 plus delta t to r.
dt0.
It's t.
It's t, yes.
Now, why? This is the delta t like we know t.
No t.
T equal delta t plus t0. This one not
Yes, this t, theta t, yes. You can see here, dt, this flash. We show that this 0. You can
Yes,
see
last.
dt.
Why is T0?
T0.
Yes?
Oh,
Where?
1. Which is the 0 of this flash. We can see this part of this U0.
Equals the differentiation of equation.
This also shows maybe t dt to the r, bigger r. Now, and this part should be
should be Buddha.
this part, the two parts. Like this, we can see
Laushi. এটা equation ভুল Buddha. Laushi,
what?
please come.
With the car? Okay.
It's easy to find. Why is like this? I do that. B T naught delta T dt.
এটা তো ডিফারেন্সিয়েশন করে না মনে হয় নাকি?
Equation ঝামেলা আছে না?
Now, this theta t, t0, maybe
0.24.
need to d.
U square to E naught delta U. যা করি এটি বলতে পারি কি তোমার ঠিক চলে যাবো বা লাশি
What?
can we come please
This part, these two should equal to each other. There is a small change. This small change
Small
can
change?
ask this t0
Yes. R.
to r equal to r u square 0 square.
Hmm.
Now these two.
ওইটা কেমনে না কি হয় এটা পাও
This is a small change. This is small change. We should limit. Give this limit. Limitation. Small change. This variation or this change is very small. So we should make these two equal to each other. And then we, by the vector equation, we can get this the second equation and the natural equation. Now, this equation also is a vector order differential equation. Vector order R. Now, the dependent variable y depends upon several excitation variables. We can see here y equal to f, x1 is 2, xm. Pinot series expressing about this operation word point x0, x1, x1 0, x2 0, now xn 0. Now we can write this little y equal to this differentiating f to x1 times theta x1 and plus the differentiating f to x2 now the same to the xm. How we can see this is differential of y equal to f x1 to xm. This equation. We can get this Taylor series expression. Now we can do next. Next we can get these exercises. Build a model for the following systems. Now there is a field. There is a force on the mesh or on the small ball. Now make it moves forward. Now the velocity is vt and m is the mass and h is this acceleration of m at time t. And then this ft is the force. Now is the force on this mass. The force applied to m for time t to t0 to t. And this vt is the velocity of the mass at the time t. And the ft is the displacement of m, the displacement of m, the x, the x t. Now, how to make the model for this system?
এগুলো দেখবো না কেউ বুঝলে
এগুলো যদি কষ্ট করে বানাই তাহলে আর কাম নাই বানাইতাম না
একটু মডেল
এটা তোমাদের ভিডিও দিয়ে নানি আমি এটা বুঝি নাই লোকি
মুভিং পার্ট
এটা
Let's wait for a moment.
Okay.
When we can discover it. Oh, okay. We can have a rest.
ওকে লাগছে
Yes.
শেষ শেষ